Good afternoon, children.
Good afternoon,
Good afternoon,
ma'am.
ma'am.
Good afternoon, ma'am.
Good afternoon, children. Yeah, I don't want to waste any more time. Let's just get started. So we finished with this one in the last class.
Yes, ma'am.
I remember I explained the working to you. Have you all completed this answer in your notebook?
Yes, ma'am.
Yes, ma'am.
All right. So I was telling you that you must first have x with a rational denominator. X is 3 plus 2 root 2. The denominator is 1. It's already rational. So x is fine. Next, we need to find 1 by x. We need to find 1 by x, which is 1 by 3 plus 2 root 2. And in 1 by x, that is the expression for 1 by x has an irrational denominator. So we need to rationalize. These are the steps. So now the denominator is rational. 1 by x is 3 minus 2 root 2 by 1. The denominator is rational. X with a rational denominator. 1 by x with a rational denominator. Next, we need to find x plus 1 by x. Next, we need to find x plus 1 by x. After having x and 1 by x with a rational denominator, we need to find x plus 1 by x. And this is what is x plus 1 by x. And since we have to find x squared plus 1 by x squared, well, we need to square this equation on both the sides. Square this equation on both the sides. And when you square it, the LHS is x squared, that is a squared plus b squared plus 2ab. We should not forget this 2ab. 2ab. So x cancels, plus 2 on the other side, minus 2. So x squared plus 1 by x squared is 34. Let's see the next one. If x is equal to 5 minus root 21 by 2, then you should prove that the value of the given expression there is 0. Prove that x cubed plus 1 by x cubed minus 5 of x squared plus 1 by x squared plus x plus 1 by x is 0. So children, please listen to me. Answer these questions. What is the expression for x? What is the expression for x?
5 minus root 21 by 2.
Is the denominator rational?
Yes, ma'am.
Yes, ma'am.
Then we have nothing to do with the expression for x. The numerator, forget the numerator. Is the denominator rational? Yes, it is rational. So x is fine. X is in the expression for x is in the right form. Next, we need to find 1 by x. We need to find 1 by x. What is 1 by x, children? What's 1 by x?
1 by 5 minus 21 by 2.
Okay, what do we understand by 1 by x? The reciprocal of x, right?
Yes, ma'am.
Then what is the reciprocal of 5 minus root 21 by 2?
2 by 5 minus root 21.
That's all. This is enough. Because x, what do we do here? The reciprocal of x is 1 by x. The reciprocal of this one is 2 by 5 minus root 21.
5 minus root 21.
Yeah, even if you write 1 by 5 minus root 21 by 2, you will get the same thing. So the reciprocal of x is 1 by x, and the reciprocal of this expression is 2 by 5 minus root 21. Now in 1 by x, is the denominator rational or irrational in 1 by x?
Irrational, ma'am.
Irrational. So
Rational.
yeah, so what is the next step? The denominator in 1 by x is irrational. So what will you do? Rational.
Make it rational.
Yeah, what is the conjugate of 5 minus root 21?
5 plus root
5 plus root
5
21.
plus root 21.
5 plus root 21. So using the conjugate, we'll rationalize the denominator. We'll rationalize and we will get 1 by x. We'll get 1 by x with a rational denominator. What will be the next step? What will be the next step? We have x with a rational denominator, or we have 1 by x with a rational denominator. Next is to find x plus 1 by x. You have to find this. It's not asked, but this is the procedure. You have to find x plus 1 by x. How will we find x plus 1 by x? That expression for x you must write plus that expression for 1 by x. You must add and get the answer. Now I'll just assume, okay, I'm just assuming. So supposing it is 10. Supposing x plus 1 by x is 10. When you square this one on both the sides, you can find the value of x squared plus 1 by x squared. When you cube it on both the sides, supposing x plus 1 by x is 10. When you cube it on both the sides, you can find the value of x cube plus 1 by x cube. Please look at the expression given. Please look at the expression. You need the value of x cube plus 1 by x cube. You need the value of x squared plus 1 by x squared. You need the value of x plus 1 by x. You'll have to substitute the values in these places, and the value of this expression should be 0. So we already have the value of x plus 1 by x. When you square, so supposing x plus 1 by x is 10. When you square that on both the sides, when you square that equation on both the sides, you can find x squared plus 1 by x squared. And when you cube that equation on both the sides, you can find the value of x cube plus 1 by x cube. Now, after finding the values of these three expressions, substitute, and you should get that the value of the whole expression to be 0. So I'll show you the answer slide, children. Please take help of that and complete the answer now in the class. The answer is on the next slide also. This is not the end of the answer, children. The answer is here. It ends in the second slide here. Yeah, please complete till x plus 1 by x. Please understand what you're writing. It's not copying from your screen. Look at the step which you're going to write. Understand and then write down. It's not copying. Done, children?
Done, ma'am.
No, ma'am.
Okay.
Now, remember, this is what we have understood. You should not multiply 2 and 5, 2 and root 21. Don't simplify the numerator. Have the numerator as it is. We'll wait for the denominator. We'll wait for the denominator to be simplified completely. See, 2 into 5 plus root 21. Don't do anything further with this. We can multiply, but we will not multiply. We'll just leave this like this and we'll wait for the denominator to be completely simplified. And when that is completely simplified, it is 4. Now you can cancel 2 and 4. You can simplify 2 and 4. 2 ones are 2 twos are. So 1 by x is 5 plus root 21 by 2. The denominator is rational. Next, we have to find, nowhere it is mentioned find x plus 1 by x. You should know to find x cube plus 1 by x cube, to find x square plus 1 by x square, you need the value of x plus 1 by x. So we are finding what is x plus 1 by x. This is x, this is x, and this is 1 by x. You should not use this 1 by x. You should not use this. You must use 1 by x with the rational denominator. That's why we have rationalized. This is x with the rational denominator. This is 1 by x with rational denominator. This one you should use, not this one. Now when you take the LCM, 2 is the common denominator, and you understand these terms in the numerator, minus root 21 plus root 21 gets cancelled. 5 plus 5 is 10. 10 by 2 is 5. So the value of x plus 1 by x is 5. Now see here. Can you see x plus 1 by x is 5? X plus 1 by x is 5. When you square on both the sides, you can find the value of x squared plus 1 by x squared. When you cube on both the sides, you can find the value of x cube plus 1 by x cube. Isn't it simple, children?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yes. Very good, children. So you need to just create this equation. X plus 1 by x is equal to what? Once you get this equation, on squaring both the sides, you can find the value of x squared plus 1 by x squared. When you cube the same equation on both the sides, you can find the value of x cube plus 1 by x cube. Now substitute. Put the values, and when you work, you will see that it is 0. And who can tell me what is a plus b the whole cube, children? 9th standard. Oh, you're still to learn this, right? You're all in 9th, right? Okay. We haven't come across this identity. I'm sorry. You're still to learn what is a plus b the whole cube. Some schools might have taught you last year. Some schools don't. They restrict it with, a plus b the whole square. So let me tell you what is a plus b the whole cube. A plus b the whole cubed is equal to a cubed plus b cubed plus 3ab into a plus b. We'll understand the derivation in the next chapter, polynomials. Now you just take this identity. Don't ask me how we get this. In the next chapter, we will see how this identity is derived. A plus b the whole cube is a cubed plus b cubed plus 3ab into a plus b. A minus b the whole cubed is a cubed minus b cubed minus 3ab into a minus b. There is another way of, having this identity. We'll see that in the next chapter. Now for this chapter, this is enough for you. Please make a note of these two identities. So look at this, children. Please look at this. What is a here? In x plus 1 by x the whole cube, what is a?
X, ma'am.
X. What is b?
1 by x.
1 by x.
Now what is the identity? A plus b the whole cube? A cubed. So see here, a cubed, x cubed. Plus b cubed, plus b cubed. See here, plus b cubed. Plus 3ab, 3 into a into b. Into a plus b, into a plus b. Can you see it? A cubed plus b cubed plus 3ab into a plus b is equal to 5 cubed is 125. 5 into 5 into 5 is 125. Now, children, what's important is this x and this x will get cancelled. So you'll have 3. X and x will get cancelled. So you have 3. And what is the value of x plus 1 by x? See here, what's the value of x plus 1 by x? 5. So use that value 5. 3 into 5. See here, this is x cube plus 1 by x cube. This x and x gets cancelled. So you'll have 3. In the bracket, you have x plus 1 by x. But what's the value of x plus 1 by x? 5. So 3 into 5 is equal to 125. Then 3 5 are 15 is transposed. It becomes minus 15. So x cube plus 1 by x cube is 110. Yes, please write down, children. Make a note of the identities. I have to clear the slide. It's very messy, so just make a note of the identities first. A plus b the whole cubed, a minus b the whole cubed.
Noted, ma'am.
Okay, Daniel. Fine, I'm clearing the slide now, children. When you're given time to write in the class, don't take screenshots. Write it now in the class. Yeah.
Completed, ma'am.
Very good. All of you done?
No, ma'am.
No, ma'am.
Okay. Finished your summer classes, children, at school?
Yes, ma'am, I know.
We still haven't received any information about the holidays, ma'am. And we have school next week, ma'am.
Okay. So maybe they're closing by April end. What about the other schools?
I'm having school, ma'am.
They closed, ma'am.
Yesterday only our school ended.
Okay.
Ma'am, sorry, I didn't say it, ma'am.
Okay, fine. We'll have summer classes till the end of April. That is the whole of next week we'll have classes. For May, I'll be sharing some of my YouTube videos with you. So we are not free in the month of May also. I'll keep you engaged. But the difference is you will not have online classes. I'll be sharing videos with you, some my YouTube videos. So we'll keep learning. In the month of May also, we'll keep learning. But you have a choice. You can watch it by the end of May. You should have completed whatever I send you for May. So maybe you can enjoy till May 20th and then start studying and then watch all the videos I send. So you're free to take your holidays, but some of us who are available at home, parents are working, we don't go out for vacations. So such students can engage themselves. So if you're going out on a vacation and you feel you cannot give us work, we need vacation, you don't have to do it. Till about May 20th or 22nd, you can enjoy your vacations, and then there'll not be too much load. So you can do it even after May 22nd. Some 1 week dedicated work, you can finish it off. So the choice is yours. Because we have a lot of portions children for 9th standard. Everything is easy, but there's lots to learn. So we have to continuously. Yes.
Ma'am, in my school, ma'am, they are now teaching me irrational numbers in number line. That spiral work they are teaching, ma'am. Will you teach that too?
Yeah. Yes.
Okay.
Ma'am, how to locate root 2, root 3, they are teaching that.
Correct. Yeah.
Completed, ma'am.
You must understand, children. I don't have to tell you this. Mostly in schools, they stick to only NCERT questions. So they will finish the chapters more quickly than we do in the classes here. Because as you can see, we do work out some other reference books. So we'll take a little longer time to complete the chapters from the textbook. Mostly at school, you'll do only NCERT. So they'll finish it very quickly.
Ma'am, in our school, we do NCERT and also Adi Sharma, ma'am.
Yeah, but it will not be in detail. They'll mostly give it to you as homework. R.D. Sharma will not be solved to the extent we do in this classroom.
Yes.
Yes or no?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah, they'll give you some. They mostly give questions for homework from other books. They'll teach you.
Yes. Adi Sharma we use for MCQ questions for homework,
Yeah,
ma'am.
that's what. Yeah, that's what. Done, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Any questions here?
No, ma'am.
No, ma'am.
Oh,
No, ma'am.
all right, children. So here, if x is equal to root 2 plus 1 by root 2 minus 1 and y is equal to root 2 minus 1 by root 2 plus 1. So can you see that y is clearly the reciprocal of x?
Yes.
Yes.
Yeah, x is the reciprocal of y. Y is the reciprocal of x. X and y are reciprocals of each other. Yes or no?
Yes, ma'am.
X and y are reciprocals of each other. Now, what is the product? What is the product of a number and its reciprocal? What is the product of a number and its reciprocal?
1.
One. So sometimes they give you the information like this. Sometimes they'll give you like this. What? They'll give you x is equal to root 2 plus 1 by root 2 minus 1. And then they'll say xy is equal to 1. That is the product of x and y is 1. They'll not give you y is equal to separately like this. They'll give you the expression for x. And then they'll give you this information xy is 1. Then find the value of x squared plus y squared plus xy. So xy is 1 meaning what? The product of x and y is 1. When is the product of x and y 1? When they are reciprocals of each other. So clearly y is equal to root 2 minus 1 by root 2 plus 1. Is this understood, children?
Yes, ma'am.
Yes. Yeah, so I'll just repeat that. So sometimes it will be given x is equal to root 5 minus root 2 by root 5 plus root 2. And xy is equal to 1. That means the product of x and y is 1. So clearly from this information, it is understood that y is equal to the reciprocal of x. Y is the reciprocal of x. So you should take y as this expression. That is the meaning of xy is equal to 1. Why have they given you this? To get the expression for y. That's all, just for that. xy is equal to 1 is just given to find y. That's all, nothing else. You can also interpret like this, xy is equal to 1, no? So you can write y is equal to 1 by x. Can you see that? Y is equal to 1 by x.
Yes, ma'am.
Yeah. So that if x and y are reciprocals of one another, that information can be given in different ways. One is they'll give you straight away like this. They'll give you straight away. They'll give you straight away like this. One is they'll give you straight away like this. Or instead of giving you straight away like this, they'll give you x alone, or they'll give you y alone. They'll give you only y. Y is this one. They'll give you y. And they'll not give x. Instead, they'll say xy is equal to 1. So you should understand that since x and y are reciprocals of each other, x is equal to root 2 plus 1 by root 2 minus 1. Or they'll give x is equal to 1 by y. So these are the different ways of saying that x and y are reciprocals of each other. Well, children, so here we are given the expression straight away. Find the value of x squared plus y squared plus xy. So this is easy. Let me just tell you the procedure. Please listen. So now we need to evaluate, we need to find the value of x squared plus y squared plus xy. Okay, now again, you can do this in 2-3 ways. I'll just explain what I have worked. You should know it's a new idea. I always believe in doing things in a different way so that we learn a new idea from that procedure. Okay, now I'm like comparing this with x squared plus y squared plus 2xy. Just imagine if you had to find the value of x squared plus y squared plus 2xy. What's the advantage? Supposing instead of x squared plus y squared,
It will be a plus b the whole square formula.
yeah, it will be x plus y the whole square. Supposing it was x squared plus y, find the value of x squared plus y squared plus 2xy, then that is nothing but x plus y the whole square. So it's so easy. I have to just have x with a rational denominator, y with a rational denominator, then find the value of x plus y and square it. That's all. I'll get this answer. I'll do it again. Supposing we have to find the value of x squared plus y squared plus 2xy. So this is nothing but x plus y the whole square. I have to find the value of x plus y the whole square. So what will be the procedure? I should have x with a rational denominator. In the question, x does not have a rational denominator, meaning the expression for x does not have a rational denominator. So we need to rationalize the denominator in x. Get that. Then we should take up y, rationalize the denominator, find that. Next, we have to find x plus y. And then that answer, if I square it, I can get x plus y the whole square, which is nothing but x square plus y square plus 2xy. So it is like this. But in this question, instead of 2xy, I have only xy. I want to make it 2xy. You know, I wish it was 2xy. It's only xy. I want it to be 2xy. So what should I do? How can I get 2xy? What should I add to get 2xy? What should be added to this expression to get 2xy? Add an xy. If you add xy, it will become 2xy. But if I do this, you'll all think I'm a very bad maths teacher. Because how can you simply add xy and change the value of the expression given? So when you give an effect like this, you should give a counter effect. That is, you should nullify this. So when you're adding xy, you should also subtract xy. That means I'm adding 0. So now you'll be happy with me. So you know I'm making sense. So see, this is your wish. Your wish is you want xy to become 2xy. So you will add xy. But again, your mind says, how can you add xy? You cannot change the value of an expression like by adding xy. So what will you do? You will subtract xy. So what have you done? You add, you say plus xy and then minus xy. That means you have nothing. It's like you didn't do any change. You didn't do any change to the expression. That is what we are going to do. We are given x square plus y square plus xy. We're going to add xy because we want 2xy and we'll subtract xy. Now these things make x square plus y square plus 2xy. And this minus xy as it is. Now this one is x plus y the whole square minus xy. So now what is the procedure? We know that xy is 1. We know that xy is 1. You can see here x into y. What will you get when you multiply x and y? Root 2 plus 1.
Since it's the reciprocal, we'll get only 1.
Yeah. When you find xy, this is x, this is y. No, I'm just telling you a very short method. Like when you multiply an expression and it's reciprocal, you will get the product as 1. You can see that here. So xy is 1. So nothing. So xy, we already know the value is 1. That means we have to find x plus y and square it and substitute the x plus y and substitute that value here. Xy is 1 and then evaluate. So see the answer here, children. See the answer here, children. I just showed you xy is 1 like using this one. X using this and this, but actually you would have rationalized x, right? I just showed you xy is 1 using this because they're reciprocals of one another. But actually xy, how you will find? Using that rational, you will use a different expression to find xy. X you would have rationalized the denominator, y you would have rationalized the denominator. See here. X is this one, rational denominator, this one. Whatever you do, you will get 1 only. The value will not change. So quickly, I'll tell you. See here, children, this is x given. This is the x. We are rationalizing. And this is the x with the rational denominator. This is y, which is given to us. Rationalizing. And this is what we get, y with a rational denominator. Next is to find x plus y. X plus y, which is 6. Next is to find xy, the product of x and y, which is 1. Now take up that expression which is to be evaluated. To that expression, add xy, subtract xy. So now from here to here, it is. From here to here, it becomes 2xy, x square, y square, 2xy, which is nothing but x plus y the whole square, minus xy. Now you found the value of x plus y, which is 6. Xy is 1. Substitute and get the answer. 35. Yes, children, start working. Videos on, please. Thank you, Prajit, Madhumita, Danya, Devadarshini, and Trishmika. Netra has excused herself. She's not well, so she's only listening to the class. Others? Thank you, children. I can't see Arjun. Done, children?
No, ma'am.
I'm going to complete, ma'am.
All right, children. Now I just have to tell you this, children. Now you should not do this. That is, you will think you have to find x squared plus y squared plus xy. Why all this procedure? X is given, so I'll just take x and square it like this. See, like this. This is the x, I'll square this. And then plus this is y. This is y. I'll square this. And x and y I'll write and multiply. You should not use this procedure. We always use expressions with rational denominator only. That is the accepted procedure. So you cannot substitute directly like this to find x squared plus y squared plus xy. You cannot substitute directly x is this, y is this, and xy and calculate like this. It's not accepted.
Completed, ma'am.
All right.
Completed, ma'am.
All right.
Ma'am, 1 minute, ma'am.
Yeah, okay.
Completed, ma'am.
Fine.
Completed, ma'am.
Fine. Okay. Can I wait for anyone else?
Completed.
Completed, ma'am.
Fine, children. All right, children. Let's see the next one. If x is equal to 1 by 3 minus root 8, find the value of x cubed minus 2x squared minus 7x plus 5. Please write the question. If x is equal to 1 by 3 minus root 8, find the value of x cubed minus 2x squared minus 7x plus 5. Done, children?
Yes, ma'am.
Yeah. So the procedure is like this. X is given to be 1 by 3. Don't read the slide ahead. Please follow me. X is equal to 1 by 3 minus root 8. Clearly the denominator is irrational. So next step, whatever be the question, whatever has to be found, irrespective of that, you have to rationalize the denominator. It's not like for this question you should rationalize, for some other question you don't have to rationalize. It's not like that. Always x is this, denominator is irrational. So next step is to rationalize the denominator. So you can see those steps here. So x is equal to 3 plus root 8. X is equal to 3 plus root 8. Till here understood, children? X is equal to 3 plus root 8. Fine.
Yes, ma'am.
Okay, next what we're going to do is to find the value of this expression, we are going to use a division algorithm. What is a division algorithm? Dividend is equal to divisor into quotient plus remainder. We are going to perform a division process. And so see, we need to get some we need to connect certain things. So to connect certain things, we now when you perform this long division, you get an equation. Dividend is equal to divisor into quotient plus remainder. You're constructing an equation. Then you can substitute and evaluate x cube minus 2x square minus 7x plus 5. So remember that to find the value of the expression x cube minus 2x square minus 7x plus 5, we are going to adopt the division algorithm. We are going to use the division algorithm. To use the division algorithm, you'll have to perform a division process. To perform a division process, you need an expression, for the dividend, and you need an expression for the divisor. The dividend is what is to be found. We'll take this one as the dividend. Divisor, now you'll have to create the divisor. You understand what's happening? To find the value of this expression, we are going to use the division algorithm. Dividend is equal to divisor into quotient plus remainder. But if you should have all these, if you should have the dividend, divisor, quotient, remainder, you should have performed a division. Only then you can use the division algorithm. I'm explaining from behind. To find the value of this expression, we are using the division algorithm. That is, dividend is equal to divisor into quotient plus remainder. Okay, use. But what is a dividend? What is a divisor? What is a quotient? What is a remainder? For this, you should perform a division process. And to get started with the division process, you need an expression for the dividend and an expression for the divisor. If you have these two, then you can find the quotient and the remainder. So that means you should start a division process. And for the division process, this will be our dividend. This will be our dividend. Now, what is a divisor? Divisor is what we're trying to find now. So see here, children, x is equal to 3 plus root 8. Now, what you do is you separate the rational and irrational. You separate the rational and irrational. Now, this 3 plus root 8, no? 3 is rational. Root 8 is irrational. So see the next step. What have I done? Can you see root 8 alone on one side?
Yes, ma'am.
Yeah, that's why you should
transfer 3 to the LHS.
Yeah. So what we're trying to do is we're trying to isolate the irrational value. Clearly, root 8 is irrational. We're trying to have that alone on any side. It can be the LHS or RHS. It should stand alone on one side. The rest of it should be on the other side. So after this, after having root 8 alone on one side, we square this on both the sides. We square this equation on both the sides. X minus 3 the whole square is equal to root 8 the whole square. We square that equation on both the sides. Now, why to square? Because I don't want the square root symbol. I want to get rid of the square root symbol. I don't want square root. I want to get rid of it. That's why, we have that root 8 alone on one side, so that when you square on both the sides, you can get rid of the square root symbol. So what is x minus 3 the whole square? So you're squaring on both sides. X minus 3 the whole square is equal to root 8 the whole square. So how do you square this x minus 3 the whole square? A square plus b square minus 2ab. A square plus b square minus 2ab is equal to root 8 the whole square is root 8 into root 8, which is root of 8 into 8, which is 8. Now take everything to one side. Now all rational. You have x and only rational numbers. You have 9, 6, 8. You have got rid of the square root symbol. You don't find the square root symbol anywhere now. Now at this stage, take everything to one side. Take all the terms to one side and equate it to 0. Take all the terms to one side. So after this, what happens is x squared plus 9 minus 6x minus 8 is equal to 0. So we have x squared minus 6x plus 9 minus 8 is plus 1 is equal to 0. Now we have got the divisor. we are going to take up this expression as the divisor. This one as a dividend. So this is the dividend. This is the dividend. Divisor is easy. From x, rationalize the denominator. Then have root 8 on one side. Square on both the sides. After squaring both the sides, you'll get rid of the square root symbol. Then get all the terms to one side. And you get x squared minus 6x plus 1 is equal to 0. Now this is the dividend. This is the, sorry, this is the divisor. This is the dividend. Perform the long division. I'll tell you the long division. Then once you're done with the long division, use the division algorithm. Dividend is equal to divisor. Can you see the divisor? Okay, I've written the quotient here. This is the divisor. This is the quotient. Okay, I've written the divisor first. I'm sorry, I've written the quotient first. Anything is fine, no? Divisor into quotient, quotient into divisor. This is the dividend. This is the quotient, divisor, remainder. Dividend is equal to divisor into quotient plus the remainder. Okay, so you can see here. This is the dividend. X squared minus 6x plus 1 is the dividend. This is the divisor. Plus the remainder. Plus, see here the plus sign. This is multiplication. Here it's multiplication. Here plus the remainder is equal to the dividend. This is the dividend. Now listen to this. So how do you multiply x into the second bracket? X into the second bracket plus 4 into the second bracket plus the remainder. See, I'll tell you again. X into the second bracket plus 4 into the second bracket. X into the second bracket plus 4 into the second bracket plus 16x plus 1. Now we know that the value of x squared minus 6x plus 1 is 0. X squared minus 6x plus 1 is 0. This is 0. So x into this one is 0 plus 4 into this one is 0. The value is 0. See, I've called this 1 and I've said using 1. Using 1. Plus 16x plus 1. So now x into 0 is 0. 4 into 0 is 0. So you're left with 16x plus 1. So that is 16 into what is x? What is x? You should use the rational denominator. What is x? 3 plus root 8. 3 plus root 8. So 16x means 16 into 3 plus root 8 plus 1. Plus 1. So 16 3s are 48. 16 into root 8 is 16 root 8 plus 1. 48 plus 1 is 49. And 16 root 8 is 16 into root of 8 is 2 into 2 into 2. So from 2 2's 1 2 comes out. From 2 2's 1 2 comes out. So it becomes 32 root 2. 32 root 2. 49 plus 32 root 2 is the value of the expression x cube minus 2x squared minus 7x plus 5. Now I want you to divide. You divide, you see how much you can recall from 8th standard, and then I'll tell you about the division. Complete the answer. Class, use the emoji. Raise your hand. Netra, Madhumita, Krishmika, Danya, Prajit, Jayant. Arjun, are you there? All right, children.
Excuse me, ma'am, I have a doubt.
Yes, Madhu.
Ma'am, in the division process, how does x square minus 6x plus 1 become x cube minus 6x square plus x, ma'am?
What I'm not able to. Where in the division? This one, huh?
Yes, ma'am. The first step. How does it become x cube minus 6x square plus x, ma'am?
So this is the first term in the divisor. X. So now this is the fine. 1 minute. This is the dividend. This is the divisor. Correct. This is the dividend. This is the divisor.
Yes, ma'am.
So we have to identify the first term in the quotient. The first term in the quotient. So for that we need to divide x cube by x square. The first term in the dividend divided by the first term in the divisor. X cube by x square. That is x. X will be the first term in the quotient. After see, that's how we identify the first term. X cube divided by x square. X cube divided by x square is x. That's the first term in the quotient. Now you should multiply all these terms with x. It's like you're multiplying x square minus 6x plus 1 with x. You need to multiply all these terms by x. So what is it? See, x into whatever you write in the quotient, x into the divisor, x square minus 6x plus 1. So x into x square is x cube. X into minus 6x is minus 6x square. X into plus 1 is plus x.
Yes, ma'am, I get it.
Okay, now that I started explaining that, let me finish it. And then you'll have to change the signs, children. So then we have to change the signs. That's what I've written down in a bracket here. This is plus, it becomes minus. Please understand that. You can put it here itself, children. So since it's, done on MS Word, I could put it down here. I'm not able to align it. The alignment changes if I try to put it here. So normally you don't have to put it below here, children. You can change it like this. Plus becomes minus, minus becomes plus. You can put it here, and plus becomes minus. Or you can put it below here like this, below here like this. Then you'll have to change the signs. So when you change the signs, x cube minus x cube gets cancelled. Minus 2x square plus 6x square plus 4x square. Minus 7x minus x. Take the new sign. Minus x minus 8x plus 5 plus 5. 5 comes down for division. Now this is the new dividend. This is the new dividend. I told you you'll have to write this and then change the signs. Then you get this as the remainder and plus 5 comes down. Now this is the new dividend. 4x square minus 8x plus 5 is a new dividend in which the first term is 4x square. So 4x square divided by x square.
It's 4, ma'am.
Is 4. That will be the second term in the quotient. Plus 4 is the second term in the quotient. Now we need to multiply 4 with x square minus 6x plus 1. So 4 into x square, that is, you need to multiply this 4 with all this here, So 4 into x square is 4x square. 4 into minus 6x is minus 24x. 4 into 1 is 4. Four x square minus 4x square. Change the signs, of course, children. Change the signs. 4x square minus 4x square cancels. Minus 8x plus 24x plus 16x. 5 minus 4 is 1. Now, how do we know that now when it is numerical, you can identify where the division ends? When it's an expression, how do you know if you have to continue the division process or if it ends there? From the power of x. What is the power of x here? 1. What's the power of x here? 2. The highest power of x here is 2. The highest power of x here is 1. So the power of x in the remainder has gone less than the power of x in the divisor. This is the divisor. This is the remainder. The highest power of x is 2 here. Here, the highest power of x is 1. The power of x in the remainder is less than the power of x, highest power of x in the divisor. That means you should stop the division. When it is equal, you should continue. So see here in the second step, in this expression or this new dividend, the highest power is 2. Here also the highest power is 2. Then you should continue. When we started, the highest power here in the dividend was 3. Here 2. So we started the division process. Then here it's equal, 2, 2, it's equal. You can continue. Now here it's gone less. If it's gone less, you cannot continue the division process. You stop there. So 16x plus 1 is the remainder, because we say the degree of x. The highest power is called the degree. The highest power is called the degree. Why do we stop the division process? Because the degree of x in the remainder is less than the degree of x in the divisor. Children, I hope nobody should get confused with this. It's changing the signs. Plus x cubed becomes minus x cubed. Minus 6x squared becomes plus 6x squared. Plus x becomes minus x. These new signs I've put it here. See, in division, children, listen to this. In division, we always subtract. In multiplication, we add. When you multiply, say a 3-digit number by a 2-digit number, you have 2 rows of numbers and you add. In division, we always subtract. So supposing we have 24 divided by, say, 5. 5 4s are 20. And we are actually not changing the sign. Actually, this plus becomes minus. That's why 24 minus 20 is 4. We are subtracting. That is, we're changing the sign. It's a plus 20. Then you should get 44. We are always changing the sign, just that we don't show it when it is now, when it is with numbers. 5 4s are 20. It's a plus 24. It's a plus 20. But how do we write 4? Because we have changed the sign. In our mind, we change the signs without even knowing that we have changed it. So 20 plus 20 becomes 5 4s are is a plus 20. 5 4s are is a plus 20. Then that plus we change it to minus. And 24 minus 20 is 4. We always subtract while dividing. So we always change the signs. It's not new. Whenever it's division, we subtract, and for subtracting, we always change the signs. So here a plus will become a minus will become a plus. Done, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right.
Yes,
so remember
ma'am.
this. So this one has a story. This answer has a story behind it. You must remember that story. You know, there are so many techniques to remember the procedure to be followed. You're not mugging anything. Now you've understood the procedure. So now how to remember this procedure? How do I know that, if this question is asked, I should work it like this? So you must tell yourself that, you're to find the value of an expression like this. This is the story you should, recall. To find the value of this expression, you're going to use the division algorithm. That is what it is. This one should come to your mind first. You're going to use the division algorithm. What is a division algorithm? Dividend is equal to divisor into quotient plus the remainder. But how do you get dividend, divisor, quotient, remainder? How can you get all these four things? Only when you perform a division process. To perform a division process, you need the dividend and divisor. This one only will be the dividend. This itself will be the dividend. And the divisor you will get by working this. By working this, you will get the divisor. How will you get the divisor by working this? First, as we always do, we rationalize the denominator. After that, we isolate root 8. We have root 8 alone on one side. And we square on both the sides to get rid of the square root symbol. And after that, we take all the terms to one side and equate it to 0. This is what we get. And we are going to take this expression. This is an equation. This full thing is an equation. From that equation, we are going to take up this expression as the divisor. This expression is taken as the divisor. So this is the dividend. This is the divisor. So the division process begins and you get two new expressions called the quotient and remainder. Put it in the division algorithm and this one is 0, this one is 0. And hence you're able to evaluate the given expression. So this is what we had to find. What is the value of this expression? That is what stands as a dividend here. The value of this expression is equal to 49 plus 32 root 2. So there's nothing to work out in this. There is nothing. Maths, once you on a daily, not meaning daily, not literally daily, I would suggest how to practice maths. Every day working one sum will not help, like a theory subject. Theory subject you can do in bits and pieces. But when it comes to a practical subject like mathematics, you need to spend hours together with it. Because only when you work about 15, 20, answers at a stretch, you will make out the difference between two sums. You will realize that, okay, that second one is to be done like that. The 15th one is to be done like this. If you work one sum every day or two sums every day, you will understand two sums, but all put together, you will get confused. Practical subjects, you must always spend a lot of time. Okay, now we have just started, so maybe you don't have much portions to revise. But once we, by the time we are in June, July, we would have completed 2-3 chapters. Then you will have a lot of things to recall. So Saturday, Sunday is the time to sit with mathematics. You must, it can go up to 3-4 hours. I'm just saying it can demand more time depending on how much you want to practice. So 3-4 hours, one chapter. You should, if possible, if you want to revise, finish off one chapter fully. Only then you will understand the difference between the different aspects in the chapter. Working two sums every day, you will simply understand two sums every day, and then everything, all the 40 sums one day, if you want to, take a test or something, you will get confused. You will not be able to make out the difference between some two questions. But when you practice at a stretch, when you work 20-30 questions at a stretch, you will realize many things. A lot of realizations will happen, and that is very important. That clarity is very important. When you look at a question, you should know that you should answer it like this. When you look at this question, you must say that this is the procedure, and your hand should start moving. No thinking. As soon as you see it, you should start working. Only then we can finish the exam paper on time or even early and revise your, check your answers. So work maths in, during weekends or holidays when you can spend 3-4 hours for the subject. And practice from the tuition notebook. That's more than sufficient. Do not use any other source. Use your school classwork notebook. Use your tuition notebook. These two sources are more than enough. Practice, repeat whatever you've understood. Don't learn new things. Many things you learn only once. You will forget. You can't remember. You will understand that at that time you will understand and you can remember it for a day or two and then it will fade away from your memory. What you can retain is what you practice, what you put to practice. You should work at least 2-3 times. You should have seen the same sum. Then it goes to your long-term memory. Otherwise, it's only in your short-term memory. Now this one will be in your short-term memory. But sometimes when we use, clues and now I told you this division algorithm and all this, if you've taken, so, and it also depends, the amount of your focus, how much you focus in the class, how much the degree of your interest, greater degree of interest, greater the retention. If you're highly focused, if if these are very interesting for you, you're highly focused, then your retention is longer. In any case, you have to practice. You have to visit the sum 2-3 times. At different times in the month, you should visit the same sum 2-3 times. Then it is shifted to your long-term memory. Then nobody can remove it from there. It stays there forever. Yes. Any questions on this one, children?
No, ma'am.
No, ma'am.
Okay. And the division, children?
Clear, ma'am.
It's clear, ma'am.
Okay.
Yeah, children. Look at this question. If A is equal to 2 minus root 5 by 2 plus root 5 and B is equal to 1 by A, that is B is the reciprocal of A. So tell me what is B?
Ma'am, it's 2 plus root 5 by 2 minus root 5.
Yeah, it is 2 plus root 5 by 2 minus root 5 because B is the reciprocal of A. It's given, that's what is given there. B is equal to 1 by, B is not equal to A. B is equal to 1 by A. B is not equal to A. B is equal to 1 by A. So B is the reciprocal of A. So B is equal to 2 plus root 5 by 2 minus root 5. Instead of giving that to you straight away, they are given you symbolically like this. Now find A square minus B square. Who can tell me the procedure? I want the the algorithm. What is the procedure to be adopted to find A square minus B square? You can do it. Yes, think. 1 minute time. Just the procedure.
Ma'am, first we should conjugate A and B and then we should square them.
Okay, fine. Any other method? Okay, that's fine, Madhumita. Yes. Rationalize A, rationalize B, then A square minus B square. Okay. Identities. Via identities.
Ma'am, A plus B into A minus B.
Very good. Yeah. Then done here. So A square minus B square is A plus B into A minus B. A plus B into A minus B is A square minus B square. So we'll first take up A, rationalize the denominator. We'll take up B, rationalize the denominator. Then we'll find A plus B. And we'll also find A minus B. Now A plus B into A minus B will give us the value of a square minus b square. So see your children. One second, I'm not getting my, yeah. So you can see here children, a, this is a, but we need to rationalize the denominator. So we multiply and divide by the conjugate. And you can see here, we got a here. Here, somewhere here, yeah, here we have a. Here we have a. Then b is the reciprocal of a. So children, see, you can take the reciprocal of 1 minute. Listen to this very carefully, children. B is a reciprocal of a. Now you will ask me, a we got here with rational denominator, and here we have something for a. Which a to take? You can take anything. You will get the same answer. Whichever you take, you will get the same answer. You cannot get different answers. Please understand this. B is equal to 1 by a. So B is equal to the reciprocal of a. Now we have a here. And we have a here also. Which a to take reciprocal? Anything you take, you will get the same answer. I have taken this one. I have taken this one. You can also take this and perform a procedure like this to rationalize the denominator. So B is equal to the reciprocal of a. So 1 by 4 root 5 minus 9. We multiply and divide by the conjugate. Multiply the numerators, multiply the denominators. A minus b into a plus b is a square minus b square. We find b. So see here, a with a rational denominator, b with a rational denominator. Then we find a plus b, a plus b. Then we find a minus b. Then that answer a plus b answer into a minus b answer. See, this is the answer for a plus b. This is the answer for a minus b. The product will give you a square minus b square, which is minus 144 root 5. Is the procedure understood, children?
Yes, ma'am.
Yeah, I'll just help you with the denominator alone, children. I think you have to complete this. You have to take a screenshot and complete this. I'll just help you with the denominator. See, denominator we get minus 1. Minus 1. So what do we do? 4 plus 5 is 9. 9 minus 4 root 5. In the numerator, we have 9 minus 4 root 5 because 4 plus 5 is 9. 9 minus 4 root 5 by minus 1. So you know 1. So you can ignore the denominator, but minus you cannot ignore. So I've told you put a bracket and then take the terms in the bracket and the numerator and take the minus sign outside it. Yes or no, children?
Yes, ma'am.
9 minus 4 root 5 in a bracket and take this minus sign up to the numerator, minus. Then what happens? You'll have to open the bracket. It will become minus 9 plus 4 root 5. Minus 9 plus 4 root 5. Because minus into minus, minus into plus. This is minus into plus, minus 9. Minus into minus plus 4 root 5. Okay. So children, so it becomes minus 9 plus 4 root 5. So here what I've done is I've just written this positive thing first. That's all. I've written 4 root 5 first and then this minus 9, then this minus 9. That's all. Now you will ask me, should you write it like that? No, not a problem. You can just leave it like this also. I wrote it like this so that taking conjugate is easy. Taking conjugate. 4 root 5 minus 9. So 4 root 5 plus 9. In the second case also, you see that you have a minus 1 in the denominator. You have a minus 1 in the denominator. So I take that minus sign to the numerator and enclose the terms in the numerator in a bracket. It becomes minus 4 root 5 minus 9. Minus 4 root 5 minus 9. Here both are negative. Yes, children, important question. Please take a screenshot. So how to remember this? A square minus B square. What is A square minus B square? A plus B into A minus B. So it's easy to find. A and B should add A plus B, A minus B, and multiply to find A square minus B square. But you cannot add A and B as it is. You must have A with a rational denominator, B with a rational denominator. So we'll have to take up A, rationalize the denominator, take up B, rationalize the denominator. Now, once we are ready with the expressions for A and B, A plus B, A minus B, A square minus B square. That's a procedure. Take a screenshot, children. Please complete this important question.
Taken.
Done.
Yeah,
Taken, ma'am.
all right. So here they are giving you the values of root 2 and root 5. And you have to find the value of 3 by 8 root 2 plus 5 root 5 plus 2 by 8 root 2 minus 5 root 5. Are the denominators conjugates? Are
Yes.
the denominators conjugates?
Yes, from the conjugates.
So either you can work this in step 1, you can work this in step 1 separately, work this in step 2 separately, and then in step 3 you can add both. See, find means what to do? You can only rationalize the denominator. After rationalizing the denominator, you should use the value of root 2 and root 5. That's all, nothing else. Now to simplify this expression, you have two methods. One is you can work step 1. You can take up only 3 by 8 root 2 plus 5 root 5 and rationalize it. In step 2, you can take up 2 by 8 root 2 minus 5 root 5 in step 2 and rationalize this. And in step 3, what you will do? In step 3, whatever answer you got in step 1 plus whatever answer you got in step 2. And you will get a new expression. In that one, you should substitute the value of root 2 and root 5 and find the value of this expression. So one method is to take this one in step 1, take this in step 2, rationalize the denominator in both step 1 and step 2. And in step 3, you can add the two answers. And when you add, you get one new, you get a result. In that result, you should use the value of root 2 and root 5. That is one way. Or I've also told you that when the denominators are conjugates of each other, you can take the LCM. You should remember all this. Otherwise, you should make a note. All this will not be worked. So I've told you if the denominators are not conjugates, you have to work in step 1 and step 2. If the denominators are conjugates, you have both the options. You can work them separately or you can work them together using LCM. See here. See here. So the LCM of, I've just taken, this is what we'll have to find. I've taken them together. I've done it in one step because the denominators are conjugates. I'm not working in step 1 and step 2. So what is the LCM? First thing, what is the LCM? The product. This product is LCM. So you can see here, the product is LCM. Come along with me, children. This is what is given. You can see the LCM here. You can see the LCM here. So you should multiply 3 with this one and 2 with this one. 3 into this one. 2 into this one. LCM. That's what we do. I told you the other day, when you have A by B plus C by D and the LCM is BD, there is B here, but it's BD, the denominator is BD, so you should multiply by D, multiply the numerator by D. Here there is only D, but the LCM is BD, so you should multiply by B, multiply the numerator by B. The same idea, same thing. This is the common denominator. You have this one. In the first term, you have this denominator. You don't have this. So multiply the numerator with what is not there. So you must. This is the denominator in the first term. This is the denominator in the second term. Multiply. The product will be the LCM. The product is the LCM. Now in the first term we have 8 root 2 plus 5 root 5. We don't have 8 root 2 minus 5 root 5. This is not there. So multiply the numerator 3 with whatever is not there. 8 root 2 minus 5 root 5. Then here we have 8 root 2 minus 5 root 5. We don't have 8 root 2 plus 5 root 5. So multiply this numerator with 8 root 2 plus 5 root 5. This is just LCM idea extended here. Now we need to multiply all this. This into this, this into this, 2 into this one and 2 into this one. And we get these 4 terms. Then root 2 and root 2 can be simplified. Root 5 and root 5 can be simplified. So for that only I've just rearranged. I've written 24 root 2. In the denominator it's a plus b into a minus b. So the a square minus b square. 8 root 2 into 8 root 2. 8 8 are 64. Root 2 into root 2 is 2. So 128. 8 8 are 64. Root 2 into root 2 is 2. So 64 into 2 is 128. And here 5 root 5 into 5 root 5. 5 5s are 25. Root 5 into root 5 is 5. 25 into 5 is 125. So children, yeah, so 24 root 2 plus 16 root 2 minus 15 root 5 plus 10 root 5. I think that step I've repeated, no? I've typed it 2 times, I think. I'll take it away once. This step I've done it 2 times. 24 root 2 plus, yeah, I've done it 2 times. Let me just remove this. So children, after this step, I've just done it 2 times. That's all, nothing else. I'll just take away this. Denominator becomes 128 and 125 children. The numerator 24 root 2, 16 root 2. You can see here. I'm just gathering the like terms. Then this one and this one, root 5, root 5. I'm just gathering. I'm not transposing. Don't change the signs. We are not transposing. We're not taking it to the other side or something. Signs will not change. Simply put the like terms and put the like terms together. Root 2 terms together, root 5 terms together. So 24 root 2, 16 root 2, 40 root 2. This one is minus 5 root 2 by 3. 128 minus 125 is 3. Now children, this is the end of rationalizing. This is over. That's all. Answer ends there. If supposing you were not given this, answer ends here, because see the denominator, it is rational. Finished. But you have to find the value of this expression. Given that root 2 and root 2 is 1.414, root 5 is 2.24. So we have some more steps. We'll have to continue. Take the value of root 2, take the value of root 5. And you know what to do. So 15.12 is the answer. The value of the expression is 15.12. Take a screenshot, children.
Taken, ma'am.
Okay, ma'am.
All right.
Taken, ma'am.
All right, children. Fine, children. Please don't forget to complete these two answers. You have two answers to complete. This one.
Yes, ma'am.
Please complete.
Yes, ma'am.
And today's work, I want all of you to take screenshots and share it on WhatsApp with me. Today's work alone. What we did in today's class, I want all of you to take clear pictures. Finish your lunch. Take pictures of your classwork and share it on WhatsApp with me. All right?
Yes, ma'am.
Yes.
Okay, ma'am.
Yes, ma'am.
All right, children. All right, children. That's it for today's session. Thank you so much.
Thank you, ma'am.
You may leave the meeting.
Thank you.
Thank you, ma'am.
Thank you, children. Thank you.